Um, Welcome back. So I'm just trying to demonstrate a simple steel truss structure, or just a simple model of a truss structure that will represent a bridge. So as you can see, it is just a very simple setup that we are trying to do here. The setup is still under construction because, as you can see, what we are trying to achieve here is we are trying to achieve a, a simply supported a pin support here, and also for the other supports we are going to have a pin support here. So then we constructed a gusset plate, something that represents a gusset plate. If this place is not clear much, so you can see it here, we are going to have a, so we have the gusset plates, and then we have the members connecting at the gusset plate, which is just a typical way of doing any major structure, mostly when you look at bridges and water towers that are constructed using steel. This is how you see it. So you see, we have, instead of doing welding, so what I decided to do is just to have my bolt here, and also to have bolts connecting the diagonal members, as you can see, connecting the diagonal members. And here we welded it. There is a weld here, and also when you look at the top part, you can see we welded here, and also here is also welded. uh, so then what we are trying to do is we are trying to conduct a dynamic test. So instead of doing, because in structural engineering we have two major type of structural analysis. We have the static analysis, and then we have the dynamic analysis. So we are trying to do the dynamic analysis on this structure. That is what we are trying to achieve. And we have our sensors, which are the accelerometer, and we have the all the other connecting instruments that we need. As you can see, we have these instruments. This is a this is a digital oscilloscope. We are going to use it, and then we have the this is a signal generator. Also, we are going to use this signal generator, and what this does is mostly we generate our signals using this signal generator. We have the dynamic shaker, but it's not here, but we have it already. It's in the lab. So the dynamic shaker, what it does is that it will excite this structure. It will excite it. We are going to put it maybe somewhere here, and then we'll have our signal generator connected to the dynamic shaker through this, and then it will excite this structure here, or we can put it here. It will excite it, then we'll get the maybe four mode shapes, the major ones. We are going to get them, and then we are going to also do a finite element analysis of this truss uh, structure that represents a bridge. So as you can see, we have our connection, but in constructing something like this, you have to understand the basic engineering judgment. You have to understand, like, how do you, what are the degree of freedoms in each, let's say, joint that you have? So what are the degree of freedom that you can have? Because this will help you to understand, and when you are doing your simulation or your finite element, these are the things that you must use, and you have to understand it very properly. So maybe I will just, okay, these are our accelerometers here. These are part of the accelerometers that we have, in which maybe we are going to connect them. We have two type of accelerometer. This is just, I think it's this is around 5, is it 50 hertz. This around 50 hertz. Then we have the ones that also, this another part of accelerometer here, but this one is programmable. You can program it, and maybe you can connect it. You can program it and connect it. um, so we are going to use the Arduino board for this work. So the basic analysis is just for you maybe to, let's say you have the structure, maybe you have it something like this, then maybe also have it so you have to understand, if you are doing a 2D analysis, like, so the degree of freedom you have at both the x axis and the y axis. So you need to understand how is this thing moving, and also this joint here and this, how are they moving. So this is just a basic principle in engineering. So pretty much these are what we are working on, and a lot of work will still be done on this structure. So anybody that is interested in work similar to this, I think this is a very interesting project, because we are going to see, because we are going to compare our result from this experimental work to the finite element, and then we are going to compare our mode shape, our natural frequencies, and we are going to compare it with the both at the experimental with the finite element. So the softwares we normally use for the finite element, you see that we have some of the softwares. You can use ANSYS, you can use Start Pro, you can use ETABS, and if you are good in programming, so you can use, if you are good in programming, I think you can use OpenSys, which these, no, those are the OpenSys.py, which is very incredible if you understand programming. So you can do a lot of programming stuff with that. So maybe let me show you maybe some of the sensors we have. I think this is my setup here. This, I've been working on the setup. It's a lot of work, but maybe if you follow us, you see a lot of the work that we are going to do. We are doing a lot. These are part of the instruments that. So this is just a normal Arduino board that we are going to connect it to this sensor, the sensor that I showed you initially. So this now, this is just a breadboard we have, and the breadboard is going to be connected to, that's what is going to connect the Arduino. So then this now will come, let's say here, this will come here, and then some other ones will also go at the different joints. You know, we have, I think we have about 1, 2, 3, 4, 5, 6, and 7, then 8, 9, 10. 11, 12, 13, 14. I think we have 14 joints. I think we have 14 joints on the structure. So if you have any question, and you can ask, and you can also share your knowledge, because this is a community. I want us to build a community that we can all share our engineering knowledge. Nobody is perfect, but at least with the small understanding of what we have, a lot of students will be able to learn a lot of things from here, and you'll be able to understand some engineering principles and some decision making, because I would love us to be doing videos related to this, so that everybody will share his own ideas and knowledge on things like this. Maybe I can maybe I can show you an actual truss that if they use something like this, they use the principle of something like this to support a water tower. Maybe I will show you outside and you can see it. So this is a real life uh, situation or engineering judgment that is being used to solve people's problem. Maybe I can just show you and then you can see. Maybe let's just, yeah. So you can see this is a water tower. This is just supposed to support that those tanks above. So it's the same principle, yes. But maybe looking at the one inside, you will see that those ones they are we use the channel sections to do the this thing. Uh, but this now we have the I sections or the I beams. Some people call it H. So this what is used, and maybe we have also this a channel section which is bigger than the one inside. The section is bigger than the one inside, so you can see it. Have this channel section, and then being supported by also this. I think this is another L section, or yes, this another L section, this another L section, then this another, or we call it angle iron. Some people call it angle iron. And these are the steps that you can go up. So you see different ways that engineers use this structural system to do a lot of different structures. Maybe if you are used to go out, you see that they use for signboard, for bridges, real bridges, you see different connections there. But this one here, they weld it. They are if you can see, it's been welded. It's also, there's no any bolt connection here, but what they did, so this interesting engineering ways of building structures. You can pretty much, if you understand how engineers come up with some of these concepts, it's very interesting. Yes, you can do your simulation to check if this will hold these water tanks or not. You can run some simulations to check if you can hold this. So maybe you can go inside. Engineering is very interesting. It's somehow difficult, but it's interesting. It's interesting if you understand it very well. It's an interesting topic. see it. It's almost the same thing. But this ones, the angle ions are just, they are smaller. The angle ions are smaller. It's almost the same thing. You see it? They are smaller than of our connections. Yes. So if you have any interesting question, or you have any question that you would like to ask, then it's free. So these are part of my setup. These are all part of the setup. So this is a 10 bolt. You see it?